Hey everybody. So now we're at the end of week 2. Hard to believe we've been out of school 2 weeks already. We're going to go over a little bit more. Yesterday was a long lesson. I'll give you that. It was a lot to digest. So that might be when you want to print out the notes and go through again. Just the parts you didn't, if there's something you got stuck on. This one should be, it's building on what we did yesterday, okay? Not quite as long though. All right, this first problem says, consider the problem a person is running a distance race at a constant rate. What time will they finish the race? Okay, so the important information I know is, first of all, it's at a constant rate, okay? What time will they finish in distance, okay? I don't know if you remember, but there is an equation for distance. It's distance is equal to whatever your constant of proportionality is times time, okay? So that's your distance. This is your time. And this would be your constant of proportionality. Okay? It is the same equation. I'm just using a D and a T instead of an X and a Y. So it's literally the same equation we've been using for everything pretty much in this chapter or unit, okay? Y equals K times X. I'm just saying Y is distance, so I used a D, and I'm saying T is time. All right, what do I need to know to solve this? Well, I need to know how far they ran. Or in other words, I need to know the distance. I need to know the time, how long they ran for. And I need to know their constant rate. And that's what my K is. That's my constant rate, okay? I need to know what was the constant rate. Okay, remember that's my constant of proportionality. So that's my K, this was my T, and this was my D. So I need to know at least 2 of those 3 things to figure out everything in that problem, okay? This is your standard equation, and it's telling me exactly what I need to know. I need to know the distance and the time, or I need to know the distance and the constant of proportionality or the rate, or I just need to know those 2, but I do need to know 2 of the 3 to keep going, okay? So those are the things you really need to know for that equation. My cat just jumped up, so he may be coming in our picture here. He's just shadowing it right now. All right, so on this page, I have the data cards written out. All this is asking us is if we have data cards. So you're just going to kind of have to play along. Let me get Olaf out of here for you because he's making a mess. All right, so the data cards are this. This is data card 1, okay? Let me move this up a little bit so that we can see the data card a little bit better. So I'm just going to kind of go through them. These are what you would have done with a partner, but I'm your partner for today. All right, so what this is telling me is it says May and Noah each leave their house at the same rate at the same time and ride their bikes to the park, okay? So it's telling me they both left at the same time. For each person, write an equation that relates the distance they traveled and the time. All right, so we know this equation. Distance is equal to whatever my constant of proportionality is times time. So in the clues they're going to give me, I need to know 2 of these 3 things, okay, in order to figure this out. That's my overall equation. All right, let's go over to, I'm going to turn this over so it's not so, I can write on the back maybe. All right, so it says, and I'm going to get it straight. I'm still going with, there we go. It says Noah lives, so I know my equation, right? My equation was distance is equal to K times time. And let's see what it gives me. Noah lives 1 kilometer farther away from the park than May does, or May. Okay, May lives 8,000 meters from the park. That's important, that's her distance. Noah lives 9,000 meters from the park. It is a, so one of them is 1 kilometer farther away from the park, okay? Which is 1,000 meters. 1,000 meters is equal to 1 kilometer, and that's what that information is telling me, okay? So I know the distance. This is my distance. It's going to be 2 separate equations because I have 2 separate people, but that's my distance. All right, they both bike at a constant rate. That's my K. All right, this one says Noah, May bikes at 250 meters per minute. And again, I'm in meters, so I'm good. And Noah is at 300 meters per minute. Okay. That is my K. Okay. That is telling me how fast they went. What I'm looking for is who went the fastest. So I'm looking for time. It's not telling me how fast they went or how fast it took them to get there. All right, so let's figure out how we would figure out our K. Remember, if distance is K times time, okay, it's telling me that they each biked at a constant rate of speed. Hers was 250 meters per 1 minute. So her distance was 8,000. She biked at 250 meters per 1 minute times, we don't know how long it took her, okay? So if I need to figure hers out, I'm going to figure it out. I'm just going to get rid of my units. I already have it to 1 equals 250 times t, okay? Now I'd solve that equation. Divide by, remember, draw your line, divide by 250. Divide by 250. Those will cancel out because 250 divided by 250 is 1, and I'm left with 1t. You know what I can do? Get rid of those zeros. If I'm dividing and I have zeros at the end, as long as they're the same, I can get rid of them. Now, how many 25s would go into 80? Okay, so if I try to figure that, this was 8,000, sorry. I forgot a 0. So now it's 800. Okay, so how many 25s would go into 800? That makes more sense. So I just divide that out. 25 goes into 800. 25 goes into 83 times. 3 times that is 75. I'm just doing some quick long division. 25 goes into 50 twice. That worked out nicely. So she was at a constant speed of 32 meters per minute. Okay, that's May's. Noah, on the other hand, let's make an equation for him. Noah, what we know about him is he went 9,000. Okay. He went at a constant speed of 300 meters, so that's my 300 meters per minute times time. Okay? That's my equation. I'm going to solve it. I would divide by 300. This one's a little bit easier. Okay. That just gives me t because 300 divided by 300 is 1t. Remember, that 0 cancels out. That 0 cancels out. 3 goes into 90 30 times. Okay. So it took Noah 30 minutes. And it took May, whatever her name is, 32 minutes. So Noah's the winner, okay? So that's one of the ones, okay? That kind of where you're gonna pick apart the information and it makes it a lot easier, all right? All right, our second problem card is this one, okay? Let me move that up. You guys get to see my lovely table here. All right. All right, this one's a little bit different because it's not talking about biking in distance. It is talking about rain, which we've seen enough of that lately, according to me. I'm trying to get these straight so I can cover up my stuff. There we go. All right, it says on here that a slow, steady rainstorm lasted all day. The rain was falling at a constant rate. So important. Okay. Write an equation that relates how much rain has fallen and how long it has been raining. All right. So instead of distance, I'm going to say like, I'm going to use y equals kx. That's my equation. I'm going to make my, that's an x. Y is equal to how much rain fell. And x is going to be my time. Okay, I could use t for time if I wanted to, but I'm going to go back to our y equals kx equation. Okay, k is my rate at which the rain fell. That's my constant rate. Okay, so in my equation, that's what all those things mean. So if I figure that out, I can kind of go through and pick out my important information. So it's telling me in these that the rainstorm lasted for 24 hours. 9.6 centimeters of rain fell during the storm. The rate of the rainfall was 2, so there's a whole bunch of information. This was our time, which in our case is our x. 9.6 centimeters of rain, that's going to kind of be like my y. That's how much fell. 2 millimeters of rain for every 30 seconds, okay? Now it's telling me there are 10 millimeters in a centimeter. There are 60 minutes in an hour, minutes, not seconds. So I don't want to know how much fell in a minute. I want to know how much fell in an hour. So if I had 2 millimeters, this is my rate, per 30 minutes, I'm going to multiply by 2 because that gives me 60 minutes or 1 hour. Because there's 2 30 minutes in an hour. I would multiply that by 2. I get 4 millimeters, okay? So first thing I did is I changed millimeters to hours. Now I'm going to say, okay, well, there's 10 millimeters in 1 centimeter, okay? Millimeters are smaller than centimeters, so I need to divide by 10. So all I'm going to do is take that decimal and move it once. It's 4.0, okay? So I would move that decimal here, and I would have 4 centimeters in 1 hour. That's my K. Okay? Now, if I figured this out, if I did 9.6 centimeters in 24 hours using 0.4, it works out. But that's not what the question's asking me, okay? I could double check myself to make sure my 0.4 was right. But what it's asking me is how long will it take for it to, for 5 centimeters of rain to fall, okay? So I'm going to put in what I know. I know that I want 5 centimeters of rain. That's how much rain. I know that it's going to fall at a constant rate of 0.4 centimeters per hour. I don't know how long it'll fall for. So that's my equation, okay? That's the equation I need to solve for question number 2. So I would just divide by 0.4, divide by 0.4. 0.4 goes into 5. Okay, I'm going to move that guy over once, which means I move that over once. Make that 50. All right, 4 goes into 5 once. 1 times 4 is 4. Again, some quick division. Bring down my 0. 4 goes into 10 twice. 2 times 4 is 8. I'm going to have to add in 1 more 0. 4 goes into 25 times. 5 times 4 is 20. So it fell for 12.5 hours. So my question to this one would be x, or my time, is equal to 12.5 hours. All right. Okay. All right, so it's kind of just breaking down every problem you have, picking out the key information, highlighting it, underlining it, whatever you got to do to figure out the key information. All right, we're going to move on. We ready? I'm going to turn my paper over. That was that whole thing. All right. I think there's only 3 pages today. Yay. All right, so we're already on the 3rd. On this one, it is saying a company is hiring, so we got to pick out our important information, right? So it's telling us that a company is hiring people to read through all the comments posted on their website to make sure they're appropriate. 4 people applied for the job and were given 1 day to show how quickly they could check the comments. Person 1 worked for 210 minutes and checked a total of 50,000 comments, okay? Person 2 worked for 200 minutes and checked 1,300 every 5 minutes, okay? I don't want to know 5 minutes, probably I want to know 1 minute. So we're going to have to go back to that. Person 3 worked for 120 minutes at a rate of, represented by C equals, that made my life easy. C is the comments, C is the comments, T is the time. Person 4 worked for 150 minutes using this equation, okay? Where it's giving me, it's kind of changing around my equation and giving me T here and C here, okay? But still, 150 minutes at a constant rate. All right, so let's figure out how many minutes each person worked, because that's what we're gonna need to do in order to solve this problem. Because question 1 is asking me, order the people from greatest to least in terms of the number of comments checked. Okay, that's easy enough to do. Order the people from least to greatest in terms of how fast they check the comments. So I'm looking at time here, and I'm looking at the amount of comments here. Okay, so let's go through this. If I'm looking at this guy, okay, he did 210 minutes. He checked a total of 50,000 comments. Well, it's already telling me he checked 50,000 comments. We'll do this in green. I don't figure anything out. So that's person 1. Person 2 worked for 200 minutes and checked 1,325 comments every 5 minutes. All right, so let's figure out how many he did per minute, because that's what these are in, okay? 1,325 per minute. So if I divide that out, I'd say 1,325 divided by 5, okay? So 5 goes into 13 twice. You get 10. I'm trying to squeeze this in here. 5 goes into 32 6 times. Bring down my 5. So he did 265 comments and worked for 200 minutes. So I'm going to do 200 times 265. Okay? What I'm really going to do is 265 times 2 and add 2 zeros. So if I do 265 times 2, I get 53,000. So that's person 2. Okay? He did 53,000. He already did more than person 1. And they're not asking how time, they're just saying as far as how many they did when they were in that period. Person 3 worked for 120 minutes at a rate of C equals 331 T, okay? So in order to figure that out, I'm gonna do 331 times the minutes. So if I did 331 times 120 minutes, okay? And I've already multiplied this out. You would just multiply that out. I got 39,720. That was person 3. Person 1 looks like he's winning so far. All right, person 4 worked 150 minutes, but I don't know how many comments he checked. Okay, so I've got to figure out how many comments he checked. So I am going to do this. I'm going to say 150 times 800. So if I have 150 minutes is equal to 3/800 times the comments he checked, okay? So I just did out the minutes was equal to how many comments? The rate of how he checked the comments. So I would do this equation, okay? And I'm gonna do it on the back of this paper because I'm out of room. You can write it wherever you'd like. So I'm gonna solve this. So I would do I'm gonna divide by 3/800, divide by 3/800, okay? These are gonna give me 1C. All right, here's my problem. I would do 150 divided by 3/800. This is my keep, flip, change. So 150 times 800 over 3, okay? Keep flip change. 3 goes in there once, 3 goes in here 50 times. So 5 times 8 is 40. I have 1, 2, 3 zeros, 1, 2, 3 zeros. So he did 40,000 comments. That was person 4. Okay, so I really pretty much have everything I need right now for question number 1. So I'm ordering them from least to greatest. Greatest to least, I mean. So the most comments was person 2. Okay, so person 2, we'll put him in purple because he's been purple, at 53,000. Okay, second place comes in person 1 at 50,000 comments. Coming in number 3 is person 4 at 40,000 comments. And then coming in last was person 3 at 39,720 comments. Okay, so that's just the total comments, okay? There's a lot going on this thing. So I just ordered them from who did the most. I don't care how long it took them. I just said who did the most to who did the greatest, or the least. All right, here's my real problem in terms of how fast they did it. All right, so now we got some figuring to do. If I figure this out, okay, I know what my equation is. My equation is actually going to be this one, okay? C is equal to 331t, or whatever it is, okay? My comments are equal to my rate times my time, okay? So remember, this is comments, this is rate, so this is the number of comments. This is the rate at which they did them, which is what I want to know. How fast did they do them? And this is the time they were given. My guess is I'm going to be looking for K. All right, so if I look at person 1, I may have to use another sheet of paper right now because I don't think I can do all these equations really quick. If I look at person 1, I know how many comments and I know how many minutes. So their equation would be, this person 1's green. They did 50,000 comments. This is person number 1 at K. I don't know how fast they did them, but I do know that they did it for 210 minutes. That's my time, okay? I can rewrite this just so it looks like a normal equation, okay? Which I can do. So if I divide this out, I'm just going to solve that equation. Divide by 210, divide by 210. Again, I can get rid of my zeros if I have that. And I get K is equal to, I've already divided this out for you just so it didn't take forever. It was 238. I just left it as a fraction, and 421s. Okay, so that's person 1. Person 2 is purple. Okay, person number 2. He did 200 minutes and he did 1325 comments every 5 minutes. Remember what we figured out, this is per minute for every 1 minute, okay? So I'm going to do the same equation. The number he did, which was 53,000, is equal to K times 265. And remember, I just want it to look like a normal equation. Oops, that's a 53. Let's try that again. Equals, it doesn't matter which way this is. It's just that's how we're used to seeing it, okay? All right, if I divide that out, I already did that too. I get, I don't know what I get. Oh, 260. So I divide by 265, divide by 265, and I get 265, okay? Apparently when I multiply that out. So I get K is equal to 265. That doesn't look right. I'll have to redivide that out. I think it's right. I did it earlier. All right, person 3 is my... All right, I know where C is the number of comments, is T is the time checked in minutes, okay? So person C, I'm gonna use the same thing. He had 39,000 is equal to his rate, okay, times his minutes, which was 120. Okay, I could do that, or I could just literally look at this and it's giving me my rate, okay, which is 331. If I divide that out, I'm gonna get 331 point something, but you get the idea, you'd get 331. So I'm really gonna look at this one. C is equal to 331T. That's my constant, so K is equal to 331. He was an easy guy. All right, and last guy, my orange guy. All right, so it's telling me time is equal to 3/800ths times C, okay? So he worked for 450 minutes at a rate of 3/800 comments, or minutes per comment. I want to know how many comments per minute, okay? So what I'm going to do is I'm going to show you one way. There's a couple ways to do this. If I have T is equal to 3/800 times C, okay? I want to get this on my other side because I want C equals. So I'm going to divide this side by 3/800. I'm going to divide this side by 3/800. And I'm going to have C equals. All right, here's the, it's not a tough part, but this is where you got to think. That looks like a mess. So if I wrote it like this, okay, T divided by 3/800. Keep, change, flip, okay. All I want to know is my constant rate, which is right here. So I would literally just divide that out, okay. I would get 266.6, repeating is what it is, times T is equal to C. And there's my rate, okay? This is my K, not the T, just that part. Okay, Y equals K times X. So I wanted to get it in the same equation everybody else was in. His was just a little backwards, so I could figure that out. I could have put my numbers in to figure it out too, but I can also solve it just using the equations they gave me. So if I'm looking at this, how fast they checked them, I'm going to look for who did it the fastest, which looks like it was person 3. Okay, so person 3, of course he did because I did that in pink. He did 331 per minute. Okay, in second place, looks like it is person 4. Person 3 was in last place last time. 4, okay, he did, what was his time? 266.6 per minute, comments per minute. All right, coming in third place, looks like it was, let's see, person 2 and then person 1. So person 2, he was at 265 per minute. And then person 1 is in last place. He was at 238 and 4/21. We're just going to say 238. I'm just rounding them. Okay, so that's how I would decide, okay? Who did it the fastest and who did the most. But if I'm hiring somebody, I probably want the fastest, okay? All right, so it said write equations for each job applicant that allows you to easily decide who's working the fastest. We did that, okay? That's what we did here, okay? So person 1, just gonna go through this kind of quick. Person number 1, we said his was, he had 50,000 comments, was equal to his K, his rate, times 210, okay? that's the equation we came up for him. These are all comments equals K times T. Your rate times your time. I don't know why they don't use a R for rate. Okay. Person 2, my colors mixed up. Like person 1 was green. Person 2 is purple. Person 2, we use this equation. Okay. So he had 53,000. That's another 0 on there. Is equal to, now he's got 538,000. K times 265. Okay. Person 3, we said in our equation 39,000, that was his total, was equal to his rate times 120 minutes. And then person 4, we said he did, where's that guy's at? Well, we had to change around his a little bit, so we were going to say that he did, how many total comments did that guy do? He did 40,000 comments is equal to K times, what was that, guys? 260, let's say 267. What was 66.6? I'll just use that. Okay, so those would be all the equations for them, guys. Okay, this one's just asking you to make a table. Okay, if I were to make a table, I would just put in all this information I know, and I'm not going to go through the whole table because it's that would be kind of boring, but this is how I would do it. I'm just going to kind of set it up. If this was person 1, 2, 3, 4, okay, I would say minutes, because those were my X. I would say comments. And then I would do comments per minute. Or Y over X. Okay, in this case, it's actually C over T, okay? So I would just put in the information I know, okay? We went through all the information. Person 1 worked 210, we'll go through one of them. He worked 210 minutes. He checked 50,000 comments. And his comments per minute were, where'd his go? 238. Okay, and then I would just do the same for everybody else. Their minutes, their comments per minute, okay? All right, I'm not gonna bore you with that whole table. All right, again, it's a lot to digest, okay? I know that, it's a lot to digest. Once it kind of clicks, it clicks because you're literally using the same equation for everything. Everything uses this equation if it's proportional. Okay, that is the equation you have to know. Everything uses that equation. I might change the y to distance, a d, and the x to time, a t, okay? I might change what it is, but it's always going to be that equation. That will help you figure out everything that's proportional. All right, I hope you guys have a fantastic weekend. I'm not sure that it's much better than weekdays lately, but I miss seeing everybody, and I will talk to you soon. Bye.